The purpose of this video is to go over how to find the area of triangles and parallelograms. Important definitions and concepts. Area is the amount of space inside the boundary of a two-dimensional shape. Area is measured in square units. Base of a polygon can be any of the sides of the polygon. Base does not necessarily mean bottom. What we're going to use when we talk about base is we're going to talk about that the base is connected to the altitude. So the altitude is a segment that is perpendicular to the line containing the base. Height is the length of the altitude. So when we talk about, for instance, area of a parallelogram equaling base times height. So you think about a parallelogram and you think about base as being bottom, but really base can be any of the sides. Height is the perpendicular distance, this here, height or altitude. It's the perpendicular distance to the line containing the base. So in this particular case, I drew the height outside the parallelogram, but if you were to extend the line that the base is on, the height is going towards the line containing the base. Or height could be drawn here, or height could be drawn here. So the idea of a base is that a base has to be connected with a perpendicular height, also known as altitude. So a couple of example type, and I just did pretty much letter A, but the idea again is that where can you draw the height? Well, height can be here, it's perpendicular. You could draw it outside the parallelogram, or you could draw it outside the parallelogram here as well. What gets harder is when you have a problem like letter B, it's a little bit harder to determine where the height actually is. So if you think about height, height is the perpendicular, so it's the altitude, the perpendicular line to the altitude containing the base. So there's the height of that particular shape, and here's the height of this particular shape. Think about when you have a car door that's just a little bit open and you kind of like throw your hip into it to close it. That's kind of what you're doing here. If the parallelogram is askew, it's been pushed, how do you have to push it in order to get that 90-degree closure right there? So the base is here, your height is here, because the height and the base are married with that 90-degree angle. It's a little bit easier to see in a triangle. Here's the height, it's the perpendicular distance. I could draw it here if I wanted, or I could draw it here, but this one makes the most sense. Again, this one's kind of askew, so if you were to extend this line, where is the perpendicular distance to the side containing that line? And it's right here. So this would be the height or the altitude, and then this would be the base. Even though they're not touching, they're married by that perpendicular line. So then the formulas, as mentioned, area of a parallelogram is equal to base times the perpendicular height. So it's not just any height, but you have to have the base has to be married to its height with that 90-degree angle. So this particular base has this particular height. So in every parallelogram, there are two pairs of bases and I guess two corresponding heights. And then here in a triangle, area of a triangle is 1/2 base times the perpendicular height. Again, notice the perpendicular that's marrying the height to the base and the perpendicular that's marrying the height to the base. So again, note that height is always perpendicular and height may be outside. I probably should have put the figure. So here are some examples. Find area of a triangle. So the area here is going to be area equals 1/2 base times height. Well, here's the base and here's the height, and I see that 90 degrees. So it's 1/2 base times height. So that's going to give me 21 units squared. Here's a parallelogram. Area is going to equal base times height again. This is where the 90 degrees is going to be. So this is the height. So the base is this side over here, which is the same length. It's 8. Which this is 5, doesn't really matter, because the idea that this 3 is here is because we have a 90-degree triangle. We're going to need Pythagorean theorem to say that 3 squared plus h squared is equal to 5 squared in order to figure out what that h squared, because we know that the base is 8. So this is 9 and 25. So when I subtract, I end up with h equaling 4. So 8 times 4 is 32 units squared. Letter C, and this one is a square. In a square, we know that there are right angles and all the sides are the same. A square is a parallelogram, so area is equaling to base times height. But in this particular shape, base and height are the same, but we don't know either. Notice that it's a 45, 45, 90 triangle. In that, the hypotenuse is equal to the leg times the square root of 2. The hypotenuse is a 15. In this case, it's the diagonal. We don't know the leg, but the leg will be both the height and the base times the square root of 2. To undo that multiplication, I'm dividing both sides by the square root of 2. So leg is equal to 15 times the square root of 2. We know that the base, which is this leg, is 15 square root 2. And the height, which is also the leg, is 15 square root 2. And this is kind of a goofy case because it's a square. So it's 15 square root 2 times 15 square root 2. Most of you are going to grab your calculators, but you can think of this mentally. When we multiply fractions, we do tops and tops. And we do bottoms and bottoms. The square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2, so we end up dividing and get 112.5 units squared. And then lastly, for letter D, this one is a rectangle. And a rectangle is a parallelogram, so area is going to equal base times height. So if this is your base and this is your height, base could also be done up here. I don't have any. Notice the 56, we have a 90-degree angle. You're going to need sine, cosine, or tangent, SOHCAHTOA, in order to get the B and to get the H. So use 56 as your reference angle. Whoops. So use 56 as your reference angle. The B is opposite the 56, the H is adjacent to the 56, and the 21 is the hypotenuse. Oops. So we are going to use sine to find B and cosine to find H. So looking at B, the sine of 56 is equal to B, which is opposite, over 21, which is hypotenuse. For finding the length of the height, which is the adjacent leg, it's going to be the cosine of 56 is equal to the height over 21, adjacent over hypotenuse. In order to get the H by itself, multiplying both sides by 21, grab those calculators. 21 times the cosine of 56, I ended up with H being 11.74. To get the B by itself, also multiplying both sides by 21. 21 times the sine of, I know that looks goofy, but it is a 5, 56 is 17.41. So I take my base times my height, and area ends up equaling 204.4 units squared, assuming I didn't screw up anywhere. All right, these are the ones that seem to stump my students every year, so read the directions. I tried to put the steps in there. It says find the area of the parallelogram using the given base and height. So if you notice, you have a given height and you have a given base. So the area of this particular shape is 10 times 12, so it's 120. I'm asking you to use that area to find the height associated with the other base. So if you notice, base by definition is any side length. So what if this were to be your base? The height would be associated with it here. So if area is equal to base times height, I know that the area of this figure is 120. The other base is 13. I'm asking what's the height that's associated with 13. We solve for H. So H ends up equaling I have 9.23. And that would be inches, if I can squeeze it in here. If we look at this other shape, all right, there's kind of a lot going on. So I see that this 9 here and the 3 here are associated with this 90 degrees. So the area is equal to 3 times 9, which is 27 meters squared. And I guess I should have put units here. So the area is 27 meters. But if you notice, this 4.5 is the other base. And what's associated with it is this height, x over here. And if you think about it, the 4.5 could really go over here. So by definition, the height is that perpendicular to the line containing the base. So if we were to extend this whole line, because the the height goes to the line containing it, these two here are a married height and base as well. So we know that the area of this shape is 27, so the base times the unknown height. So we need to do 27 divided by 4.5, and I end up with 6. So whether I use the red combination of numbers or the purple combination of numbers, area will still be 27. And it's the same there with letter A as well. And then lastly, Bob the Builder wants to know how many square feet will need to be paved, and of course it's dizzy mixing the cement. But we have a parking lot with flowers, so notice that it's made up of a rectangle. We have triangular flower beds, and these, what shape is that? It's a parallelogram of a parking spot. This problem can be done several different ways. Some students like to find the area of the whole big thing and then subtract out the flowers because they're the things not getting paved. Some students like to find the area of the rectangle and add it to the 4 areas of the parallelogram. It's completely up to you. One thing that I think needs to be done first is to go through and label. If this whole length is 50, then this whole side length here is 50. But notice that each of these amounts is 10. So that means this is 10. Let's see here. This amount is 15. So if that amount is 15, 31 minus 15 is going to be 16. The area of this triangle is 1/2, 16 times 10, so 8 times 10 is 80. But then this one's also 80, so there are really 1,600 square feet worth of flowers. So I'm going to take this entire box, the 50 times the 31. 50 times 31 is 1,550 feet squared, and that's not a negative, that was just my pen moving. So if I have 1,550 whole square feet, the parts not getting paved are these flower beds. So I'm going to subtract away the flower beds from that number. And Bob needs 1,390 square feet to be paved. So that concludes this lesson. It was done rather quickly under the pretense that we've seen area of a triangle and parallelogram before, but I've just ramped it up to the high school standard of area and parallelogram. Please let me know if you have any questions. Thank you.